Thank you for attending our session on scaling Spring Boot applications in real time. My name is John Blum, and with me today is my friend and colleague, Luke Shannon. We both work for Pivotal. I'm actually on the Spring data team, and Luke is a Pivotal architect who works with a lot of our customers on a lot of the technologies and some of the problems that we're going to actually discuss today. So let's get started. This is actually a talk that we kind of rejiggered from last year a little bit. So our story is kind of similar, but we kind of spun it in a new direction this year. So if you've seen it from last year, it'll be different, but the messaging is sort of the same. How many people are on this journey? A few people? Pushing up to the cloud? I'm sure by now everybody knows what microservices are. You know, decomposing your monolithic application into smaller services and trying to do more with your capacity, your resources, and all to scale your applications. And why do we scale? Well, we have more demand on our services, our applications, not only just users, but devices, right? Mobile devices, laptops, pads, multitudes of devices on all the time, constantly. However, this journey can kind of look something a little bit like this after some time. Gets a little turbulent, and things don't go quite as well as you expect. It's obviously a lot easier to do with a newer application than an existing application. But in reality, we have a whole bunch of existing applications. So what do we do with all of those? Well, it's not as simple as just taking this thing and throwing it in here and then adding more resources and expecting everything to work fine, right? Because the world's a little bit different now in our microservices world, our cloud-native architectures, things are a little bit different. A lot more servers, a lot more distribution. You have to worry about consistency. You have to worry about failover, all these things. But you still have this existing application, so what do you do with it? How do we migrate that to the cloud? Well, we can start looking at things internal to this application. We want to still maintain this existing application because we've invested a lot of time, effort into running this thing, provisioning it, caring for it over all these years. Still a value add to our service. So we can start looking internally to this application a little bit in terms of what we can do with the application itself without having to try to tear it apart. So we're going to try to avoid just diving headfirst into microservices here. So if we look inside this application, we have something that looks a little bit like this. We have our client tier. We have our services tier that contains all of our business logic. This is nothing new to anybody here, I'm sure. And we have our data source. And we get some users, and everything's running fine. No problems. However, as we add more users, we start to have a problem because now our application server is under load, right? Can't handle all the requests anymore. And naturally, we'll just add more instances of that. That's not too hard to do because we used to just stand up additional application servers and deploy our application in that server. And we would only run one app in that application server because, well, we wanted isolation. If that app goes down, we didn't want it to affect a bunch of other applications that were potentially hosted on that same application server. So we had multiple licenses for all these application servers, and we're scaling them all out. But as we add more applications, of course, now we're going to put some strain on our data source. And if that's a database, we're obviously already constrained by disk access. So we naturally just scale it up. We'll add more CPU, we'll add more disk, we'll maybe increase our network bandwidth. If we're really savvy, you can shard your database, but that's not trivial to do in Oracle if anybody's ever tried to do that before. Or commonly called partitioning their database as well. But as we grow in users, as we continue to get more and more load, the complexity grows. The latencies grow, so we tend to push more logic and responsibility to the database. We start writing stored procedures or functions, right? We're inherently coupled to that database at this point, which is very hard to migrate away from it when we're in a cloud environment, like AWS or something else. Like we're really dependent on what we've done in our database. We've vetted that for years. We've added indexes. We've added functions that we've tested and hardened for years and years. And how do you unwind all that? So that complexity is obviously causing our projects to go over time and over budget, and that's not a good thing. So let's go back to the beginning of where we're at in this existing application architecture, trying to push this to the cloud. Now, one of the quickest and easiest wins for actually putting your application into the cloud space is caching, right? That's not a new concept either, right? We're all familiar with look-aside caching. It's a very common pattern. Spring's cache abstraction is an implementation of the look-aside pattern simplified. Makes it really easy to do. How many people are familiar with look-aside caching? Okay, we got a few people. Some people, it's interesting, they haven't actually used the cache abstraction before, but essentially the cache abstraction is just an abstraction. There's no provider implementation, so you plug in a provider implementation. That's the beauty of Spring's cache abstraction, is that it supports a wide array of providers. And one of the providers we're going to talk about today, we're going to get more to the end of the slides where we delve into the real details of what this technology is, but is Apache Geode here. And it's a very sophisticated caching solution. But in a nutshell, for the people that are not as familiar with look-aside caching, the way it works is you basically add caching to your services tier in your service methods call. Like maybe you're looking up a customer by name, they call in, phone number, whatever, and you go and look it up in the cache first instead of going directly to your data source and running a query. If it finds it, it'll just return it. No problem. We didn't have to go to our data source. We didn't have to access any disk or maybe potentially make an expensive network hop. However, if it doesn't find it, it will go and fetch it from the database, or the data source of any kind, really. And then it returns it, sticks it in the cache, and then returns it to our service. Pretty simple. There's an additional form of caching called near caching, where we can actually bring the cache closer to our application so that you remove potential latency and network hops and that sort of thing. And essentially, each of your applications can actually embed a cache that talks to a server cache. I've kind of positioned this to be sort of a client server, and we're going to take a look at what that looks like here with an example. So let me jump over to my IDE. Okay. Blow this up a little bit. So I got a few things going on here. Actually, this is quite dirty at the moment, so let me remove some stuff. Okay. So it's just your typical Spring Boot application. And you have your main method. Nothing new there if you're familiar with Spring Boot. How many people use Spring Boot? Awesome. A lot of hands there. So you're probably already pretty familiar with the setup in this basic Spring Boot application. You just annotate it at Spring Boot application, create a main method, use the builder or the Spring application class, and give it some configuration. You're off and running. So what I got here today is a geocoding service. So your data source isn't necessarily a database. It could be another data service, right? And a good example of that might be you have an application that you need to geocode some addresses. And you want to maybe show something on a map. And more likely than not, you would be using some sort of geocoding API, like Google Maps, for instance. And this example actually has maps built in, but for today's purposes, I've actually mocked that out because I don't want to have any issues with the network. But it does work, and the actual example is in this repository for people to experiment with later. But the geocoding service is pretty simple. It's just a service class, a Spring service class that takes a geocoding repository. And the reason why I broke it into the service class is for a couple of reasons. One is I wanted to separate the logic of actually doing the geocoding from the service class, which will handle things like, was this a cache miss or not? So I got some logic in there that'll tell us where we actually had a cache miss, or we had a cache hit when we actually introduced caching. But right now, this application is not using caching. In addition to that, we can actually plug in different providers. So like if I wanted to swap my mock thing with Google or TomTom or another service that does geocoding, we can easily swap that out and keep that agnostic of our service. The repository just basically does two things. It geocodes an address object, returns a point, and takes a point, and can reverse geocode that. Most geocoding services actually have both directions there, so it's quite interesting. And like I said, we just have a mock one. So this guy is basically literally just simulating an expensive service by sleeping. But like I said, there is a Google Maps API geocoding repository, which uses the API that Google provides to access their Google Maps. But you need an API key to actually interface with that as well. So you have to register for GCP and get your API key and then associate it with an account now so they can bill you if necessary. So we're not going to go there. So we're just going to use this mock guy, which basically serves our purpose. But I assure you that the Google one works just fine. In fact, this coordinate here actually came from Google itself. And that address is just the Pivotal office in San Francisco. So if I just run this guy as is, it's got a 2-second sleep there. It's going to spin up our Spring Boot application here in just a second. So it's quite slow, right? We got 4 addresses, and what you can see there is I've got, I think I can expand this guy. Yeah, there we go. All right. So we got the addresses coming in. So hopefully everybody can see this. Oh, it's not going to work here, sorry. So at the very bottom there, you can see that the first address was a miss. They're all misses, actually, because I don't have caching there, and they all take a very long time. Very expensive, right? So how can we simplify this with caching? How can we make this quicker? Simple. The first thing we want to do is we want to introduce caching to our service. So since we're passing in an address and we're getting a point, that's our intensive operation. So I'm just going to add caching there. So if you're familiar with Spring's cache abstraction, or perhaps you're familiar with the JCache API, JSR 107, there's annotations there. Spring also supports those annotations. So this is just a caching annotation in Spring that says, okay, we're going to look in this cache first to see whether this operation has already been performed. With a well-known input that returns consistent output, I take that address, I pass in the same address every time, I'll just look it up in the cache, by that address object, and if there's already a point, just return it. Don't actually go and invoke this method. Therefore, we wouldn't expect to see cache miss set to true. However, we're not quite done yet. If you've used some of the other caching providers in Spring, especially with Spring Boot, you have to define your caches. If you're using something like Redis, you have to literally set a property that says, here's all the names of your caches, right? Well, I did one better. In Spring Boot for Apache Geode, I just said @enable enable caching defined regions. So in Geode, the caching solution that we're using, you can kind of equate it to a database in a sense. The cache is kind of like the schema, and the regions of the cache are like tables in a database. So you can have multiple different regions for different purposes. Store your customers, store addresses, for instance, and so on and so forth. So to make this real simple, if you have literally hundreds of different cache services, different caches that store different things, you don't have to go and create regions for all those things, or the equivalent of specifying the name of every single one of those caches so that it creates that for you. And in this particular case, we're just going to run it as a local region, so we don't expect to have any server connected up to this. All right, if we run it again, we would expect to see our runtimes improve dramatically. So the first one's always going to be slow, right, because it hasn't done that before. And so the one that it redoes, that's the third one here, the Howard Street one, you can see it was not a cache miss, and the time was only 3 milliseconds. And you can optimize that quite a bit. I mean, so that it's literally virtually zero. I didn't spend any time optimizing it. I just wanted to show you the effect of the fact that it literally didn't call that method because there was no 2-second wait there. That's 2,029 milliseconds the first time it geocoded Howard Street address because it invoked the method to go to do the geocode operation. And on the second time, it actually hit the cache and just returned it. OK. Going back to our slides. So we're going to come back to that example in just a minute. But we're going to move forward and talk about distributed computing. Everybody here is probably familiar with Hadoop and how it popularized a map reduce pattern, right? I map out a bunch of functions that do a bunch of work and aggregate it and send it all back, the reducing part. Well, in the Apache Geode solution for caching, it's more than just a cache. It's not a simple cache, right? It's not like EH-cache or MIM-cache or something like that. It's not even really equivalent to Redis. There's a lot of more features in Geode that extend well beyond that. And we're going to get to some of those a little bit later in our talk. But one of the more powerful features is functions. Not unlike a stored procedure or a database function in particular. But the difference being is that right now we're pushing our logic down in the database so we can get the logic closer to our data. What we really want is remove that, right? We don't want to be too coupled to our data source. We want to bring that back out. So if we just reposition Geode a little bit between our application and our data source, we can actually uplift that logic again. We can actually start coding back in Java, right? We don't have to I mean, I know that certain databases support Java-based stored procedures and everything, but at some point you're still kind of coupled to your database. So in this particular sense, you can just write pure POJOs for your logic. And the Spring Boot aspect for Apache Geode makes it real simple to actually both create those functions and execute them because they don't look any different than any other object method. So let's take a look at what that looks like right now in this example. So I'm going to expand on that geocoding example a little bit and show you some functions. Okay. So what I have over here now is we're going to actually start entering this client-server mode. Right now, like when I did the caching, I just did a local region. And that's not really practical, right? Because if that client goes down, then nobody else sees the results of that caching operation. We really want to send it to the server so all clients that are connected to the cluster see that geocoded address. They don't have to make the call of geocoding themselves. So what I've done right now is I've actually created a server, and it's going to add some addresses, and it's going to register a function. So we're going to take a look at that function. So you can see down here in my runner, all it does is it gets an address repository for the address object. If you're familiar with Spring Data's repository abstraction, it's real simple to create repositories. And we're already kind of alluding to that we're moving well beyond a cache at this point, not using it just for caching, but we're also using it as sort of a system of record. But we'll talk about that later. But by the fact that the address repository is here, we've already kind of moved beyond just simple caching. But in this particular case, I just want to persist the two addresses that didn't actually get geocoded the first time, right? So that when we reconnect that client, we can see the effects of the caching. But what the function looks like, it's real simple too. So this is the function I'm talking about. We're going to talk about that region concept a little bit more, but what this does is it fires a function out to all the nodes in your cluster. So if all the nodes are hosting this region address to location, it's going to fire that function out to every single node in that cluster that has that region and run that function on that region. And it's only going to run the function on the local data set of that node. Because if it had to query, it's going to have to go out across the cluster and pull in a bunch of data. We don't want that, right? We don't want to have to go out and have a bunch of network hops. We don't want to just operate on that local data set. So by just annotating this function, first I annotate it with GemFire function. So this is the Spring Data GemFire or Spring Data Geode annotation for saying that this method on this class is a proper geode function. And then I can annotate a map, because a region in GemFire or Geode is just a simple map, right? I can actually just get the local data set by using @region data annotation. So that gives me the local data set for that node. I can operate on it by basically saying, iterate through all the addresses and geocode them. You might have like another disparate service out there that's running in the background, and maybe another client that's actually feeding your address database and or your address data store, and doesn't have any geocoding capabilities, right? But you want to run this function now. You could, of course, run it as a batch job. You could run it in clients that are smart, like up front when an address comes in, you could geocode that up front. But if you have like a mixture of other clients in your architecture that doesn't have this capability, you can still run this sort of batch-like job, but in real time, real quickly, through a distributed function execution. So that's all this function is doing. It's just basically getting all the addresses and geocoding them, adding them to the other region, address to location. So if I run this guy, this is running right now. He'll start up, and he'll add those addresses, and he'll make that function available. To make that a little bit more apparent, let's just jump over to the shell. So there's a shell tool for Geode called gfish, or GemFire or Geode shell. I keep mixing the two terms, GemFire and Geode. We're going to explore that later. Really, they're one and the same thing. GemFire is offered by Pivotal. The open source version is Apache Geode. Again, we'll talk about that in a minute. I can actually connect to this node. It's actually a Spring Boot application that literally is a server node in a cluster, and it could connect to other nodes. All right, so we list the members. We're going to see our geocoding function server there. We're going to see our regions that I was talking about. So we have our addresses table that's just storing our addresses regions that's just storing addresses. And then the geocoding function is going to take all those addresses, geocode them, and then write that result to the address to location cache or region, which is what our cacheable service was using, right? So we can even see the functions. There's actually a few other functions that get registered when you're using Spring Data Geode. But you can see there below, you can see our geocoded addresses function. So you could actually invoke this through gfish, but I actually want to show you what it looks like when you invoke it through Java. So we've seen the implementation side. It's real simple, right? We just have this method on a class. It's just a bean in the Spring application context. Gets registered, and Spring Data GemFire or Geode figures out what you need to do with that function by default. You don't need to specify any enabled GemFire functions or execution annotations. We're using Spring Boot. Spring Boot sees this in your application structure, and it just registers it for you. You don't have to do anything. You just create it. On the client side, if I wanted to invoke it, the only thing I need to do is define an interface with a method that corresponds to the ID of the function that gets registered. And by default, in our implementation, when we actually created this function, if I don't specify an ID, this annotation has a bunch of attributes on it. If I could type, it would help. So I could say ID and give it an actual specific name. But if I don't give it a name, it's just the name of the method. So over here, I just have to make sure the method name's the same. If it's not, then I can actually use a client-side annotations like function ID and just link those up that way. But I tell this function which region it's going to execute on. From the executing side, this is the client side now. This is literally a client connecting to that server, and it just invokes this. So over here in our Spring Boot client application, all we do is we inject that function execution as any other object. It's just an interface. And Spring Data for Apache Geode or Geode is going to provide you the implementation of that execution for you. It's going to provide the logistics to be able to call that function on the server. You told it how to kind of call it by using this on-region annotation. And then you inject it like any other object, and you invoke the method. So you're literally invoking a function in the server at this point. It's really that simple. So if we run this guy, well, let's jump back to gfish for just 1 minute. I want to actually describe the region. So I want to describe addresses first. You'll see that there's actually 2 addresses there that the server added. Should have did this before, my apologies. Okay, so we have a size of 2. And if we describe the address to location, right now we don't have anything. We have a size of 0. So when we run this client, we would expect it to geocode that stuff. Okay, it's geocoding addresses. Again, I didn't really optimize things, so it runs a little slower than expected, but still pretty quick. And now we have some addresses. We have some geocoded addresses in there. So let's go back to our caching example. Now, if I want to actually turn this geocoding service application into a client-server architecture, right now it's local, right? If I want to turn it into a client server, just remove that. Now it's going to expect to connect to a server, and it's using some defaults by default, so it doesn't, like if you want to change up your ports, if you want to change the way your cluster connects, your peers, your clients connect to that, you of course can do that. But out of the box, the intent is to make it very simple to do that. Like we don't want you to have to fuss with, figuring out which ports to which nodes, and if I'm adding a lot of members, having to mangle all that stuff. So by default, it just uses some defaults out of the box. It gets you going real quickly. So I just removed that. And now what we would expect to see is that everything but Howard Street, because back here in our server, right, we didn't have, where'd my server go? Here it is. We only did Boulder, Colorado address and then the Beaverton address. So this is the only one that should be slow. All these other ones should just cruise. Well, the Howard one will be fast the second time because it hit the cache, or it hit the service method and realized it wasn't in the cache. It geocodes that and then puts it in the cache. So the second call will be fast. Every call after the first one is going to be really quick. So hopefully that's the case. All right, cruise through that. So that first one took a lot of time. The last 3, no time whatsoever. And that was all just by populating the cache on the server side, doing some work there, maybe invoking a function. Of course, like I said, you could do it as a batch job, a nightly batch job. You could have smarter clients that geocode that up front. But what I really wanted to do is show you this sort of like batch-like job running in real time very quickly and very easy to do. Yeah, absolutely.
So when that was removed, does it also keep your time?
Yeah, oh, good point. Thank you for bringing that back up. So what if I wanted to have that near cache, right? Like I mentioned that in my slide. How would I do a near cache? Well, that's real simple to do too. Remember that client region shortcut where we were just doing local? Client region shortcut, caching proxy. Now that client application literally has a client local cache that gets synced up with the server. And any keys that client node has will be, if you register interest, it'll get the updates for that locally. So pretty simple. Another question?
Yeah, so could we configure that like in config as opposed to via annotations?
Yes. So what I'm showing you today is all via the annotations because it's really quick and dirty to do from a development perspective. But literally a lot of these annotations, I don't talk about it frequently because it's a lot more involved. But there's actual, for the annotations, if you look at all the attributes, there's corresponding well-known properties. In addition to that, there's also configurers. So if you're familiar with like Spring Web MVC, you know how you have those configurers, you can register to tweak certain parts of the MVC configuration. So there's a configurer that'll give you a handle to the client cache factory bean. And from there, that's before it actually even constructs the client region. You can control the initialization that way as well. But yep, you have a lot of flexibility. Good question, thank you. Okay. Let's jump back to the slides. Yep. So we haven't really talked about scaling too much, right? We got a client server going on, but we really haven't talked about the scaling aspect of this. So we don't really want to necessarily scale our data source, prematurely. That might be too costly, especially if we were scaling up. The great thing about Apache Geode is it scales out linearly, right, horizontally. So I can just add more servers. And it's a shared nothing architecture, so these things pretty much operate independently of each other. But when they're all connected, they will all coordinate with each other and work in tandem as well. In that manner, we can actually reduce the capacity that we've put in our data layer. And if we're lucky, we might even be able to get rid of that complex architecture and reduce it back to our single data source. There's some additional features that Geode provides to you. I already alluded to the fact that you could use it as a system of record. So there's a few other things that make this technology even more valuable. You can actually configure your caching layer to write through to the database using a cache writer, or conversely, actually load from the database using a cache loader. So if it results in a miss, you can configure a cache loader connected to your data source and pull that in. That's what we call inline caching. If you don't want the synchronous nature of that, which really helps from a consistency standpoint, but if you're not so concerned with the consistency, you can do that asyncly. So you can actually attach what we call an asynchronous event queue, attach a listener to that, and it'll write behind. So the cache operation will happen, fire the listener, and that'll happen sometime later. You can configure single hop data access between the clients and the servers. So what that allows you to do is if you configure your cluster to get metadata about where those servers are and where the nodes that host certain data, it'll send that metadata down to the clients, and the clients will know exactly where those nodes are with the data that they're interested in and go directly to that node. If you don't have single hop configured, then it's likely, well, possibly likely that you would connect to a server that doesn't have your data. It would make another hop to go fetch it from that server, bring it back to that server, and then tell your client. But with single hop access, it can go directly to the server that has your data. It also has multi-site WAN capability. So it's not enough anymore to just have a caching solution that is client-server. We can also do this distributedly across different regions. And one of my other favorite features of this caching technology is continuous queries, which is an event streaming mechanism. And I'm not going to say too much about that because I don't want to steal Luke's thunder. I'm going to give him a chance to talk now and tell you guys a little bit more about continuous queries and event streaming.
And scale.
And scale, more importantly, scale, yes. All right, example time. So are there any questions up to this point about what we just covered so far? Yep, excellent question. So the question was, how about the time of expiration for the cache? And that's actually in some later slides that we have where we can talk about expiration, and there's also the option of eviction. So memory is obviously very important in something like an in-memory data grid, like Apache Geode. Therefore, you have to manage that memory intelligently. And there's a few ways in which Geo does that. One is expiration on your data. There's different types of actions that you can take on expiration, like destroying that, invalidating that entry, and so on. There's also eviction, where you can evict least recently used items from the cache, which is important in cases where you want to keep your cache fresh with your latest set of the most important data, right? But you don't have to necessarily lose that because you can overflow that to disk. You can even make that persistent. We also support things like compression, so you can compress the data in memory. And there's also an off-heap option. So there's a lot of different options when it comes to managing memory, but yes, eviction and expiration is two of them. It's configurable, and it's pretty much automatic. Please come see me after this talk, and we'll talk about that more.
OK, hopefully everyone can hear me. So we have a small little demo application that we want to play with here that suffers from some of the problems John showed initially and also demonstrates some of the features that John mentioned previously. So I'm using PWS. So it's running on Cloud Foundry. So this is a managed version of Cloud Foundry. And what this is a really simple chat application. So what I can do is join, so I can put my name, and I can enter. So I can say, hi there. And you can see there's some previous messages. So there's my message. And I might open from another window. Just steal that URL. Just create another session. And I'll impersonate John here. So he's going to get all the messages shortly. And he can say something. And then if I go back to my original session, I can see I'm getting these messages. So this is actually a database-driven application. So let's take a quick peek at how this works. So what happens is we have hopefully we can see this. We have a message POJO. So I'm using Lombok here. It's pretty skinny. But the main thing you can see is the @entity and @ID. My repo, I'm using Spring Data JPA repository. So that gives me pretty much all I need for CRUD operations. And you can see here I'm persisting messages with an ID of long. And then if we come in here to the message service, what happens is when a client on that UI posts a message, the message gets written to the database. So you can see there, saves the message. And then what we have is we're using Spring Scheduler, and we're doing an @scheduled on a fixed rate of 5 seconds. We're getting all the messages, and we're putting them on a WebSocket. So what we've done here is configured a very simple WebSocket, some endpoints here. So you can register with the Stomp client. So you can see I've got an endpoint to register with messages there. And if we come into this UI, I'm just using Timeleaf and Spring and just basic JavaScript. You'll see I actually register a Stomp client. And every time a session is created, it subscribes to that topic message, which is where we're writing the messages. So essentially, you post a message, it gets written to the database, and then we're pulling the database, we put it on the WebSocket, and then the UI just writes it for us. And I use Mustache just to make it a little bit nicer, but essentially that's how this works. And it works pretty well. Now, there is a challenge. So everyone's chatting away here and things are fine. What I want to do is put some load on this particular application. So here is the console in PWS. So you can see we have one instance of this application. So to get into the cloud and to really take advantage of things, we want to be able to scale. So what I'm going to do is configure auto-scaling. And just to illustrate this a little easier, I've got CPU utilization at 10% to scale down. And if it goes over 11%, I'm going to scale up. So, there's only so much load I can create here. So now what I'm going to do is I'm going to come in, and I've got a super simple application here. What this app does is it's a Spring Boot app, and when it starts up, it just uses REST template and just posts messages to that message endpoint. So it just does it infinitely. So let's start this up. So what we have now are just messages getting hammered at that chat application every second, right? So if we go back to PWS, you can see it's actually, the Autoscaler has kicked off not one, but 2 more instances. So it's like, oh gosh, there's a lot of load here. CPU is getting hammered. Let's scale this application up. Now you'll notice that app crashed when it tried to scale. And PCF is really good. It's going to actually try and start it up again. But it's going to keep crashing. And this log is going to be very polluted with things, but we should be able to kind of scroll around and find out why it crashed. In theory, it's a lot of messages. Maybe I'll turn off the messages for a second. Come on, man. This worked earlier. Is that it? No. Here we go. So it's a little bit hard to read, but this error is actually coming from Hibernate, and it's turning out that the new application spinning up couldn't get a JDBC connection. So what's happening is the database that's backing this is a tiny bit brittle. So it kind of freaks out when too many things try and connect to it. Now, naturally, you could say, well, you can sort of improve that. You could sort of do various things with that. But this thing could become very popular, right? So what we want to do is maybe explore Geode as a way to create a more scalable backend to match our scalable front end. So as a result, though, unfortunately, to this limitation, we're only stuck. So those other 2 keep crashing, and we're only stuck with that one application. So I'm just gonna kill this. So we stop hitting on this guy, and that's killed. And I'm just going to shut him down. OK, so let's take a look. So the first thing, what I want to do is I want to put Geode as my backend of this application. So I want to put all my chat messages into Geode, get Geode to send them up, and then I can scale Geode. And like John said, if I want to keep my database, I could actually have Geode batch the messages up and write them asynchronously to the database and do it in a fashion that isn't so overwhelming and consistent like scaling applications with JDBC connection pools might be. So let's take a look. We'll start. I'll just close all these. We'll just do a quick comparison. So coming back to our message POJO, so that's there. Let's see what the message POJO for Apache Geode would look like. Just do a quick comparison here. So you can see @entity has been replaced with something called region messages. So as John said, regions, it's like a distributed map across the cluster. So rather than writing to a table, we're actually going to be putting the object itself into that messages region. So not a massive change there. That wasn't too painful. So how about the repository? So if we come to the repository, there's my JPA repository. Here is what the repository looks like to write to Geode. So again, it's extending a Spring Data repository, except instead of JPA repository, I just went with CRUD repository. But I'm still writing my POJO, and I'm still using the same ID, except that ID is a key, because Geode is a key value store. Now, we didn't have to do this, but, well, we kind of did. There was some sorting issues because the order of the chats wasn't maintained quite the same way as the database. So here's an example you can see. I can do custom queries just like I would any other JPA repository. And Geode has a query language called OQL. It's not quite the same as SQL, but it has a lot of things similar. But also, as you can see here, because everything is an object, you can actually call the methods. So some of the attributes coming back, because they're objects, we can call the methods of those as part of our query string. So again, not a major change there. So the biggest change is in the service. So our service for JPA had quite a bit going on. Let's see how it looks for Geode. Actually, let's see if I can. There. So our service for JPA, we basically took the object and wrote to the data store. For Geode, we're taking the object and writing to the data store. So we actually writing the messages to our persistent backend. We actually didn't even have to change anything. Basically just that one annotation. Here's where the interesting part comes. So notice that I have an @schedule fixed thing, and I'm hammering the database with that query. With GemFire or Geode, I can actually do something called continuous query. What continuous query does is it pushes new chats that have been entered into the data store up to the client. So rather than pulling to the back end, I just receive messages. So it's kind of, instead of pushing, instead of pulling, you're actually getting your messages pushed. So this is actually far more efficient, and you can see it's pretty eloquent, and I can sort of add customizations in that OQL to get very specific about the type of messages I get back, right? Other than that, and you can see here there's some code, but in the end it just writes to the socket the same way that JDBC did. So let's take a look at this. Every other aspect is different. I mean, the last thing I guess we would want to note is in the JPA version, we had Spring Data JPA. The only other magic we sort of have here is Spring Geode Starter. So Spring Data JPA was swapped out for Spring Geode Starter. And of course, it knows how to connect to the cluster, which I'll explain what that is in a second, with some property files in my application properties. So my cluster is running in AWS, and this explains how this client application is going to hook up to that, so that continuous query will work and everything will work. So this application is running in PWS. So it's called Chat Web App Geode, and it's running one instance. Now, my Geode cluster is just running on AWS, and there was really nothing special I had to do here. So I had two processes called locators. So these are sort of members that clients can talk to, and they're sort of the entry point. And then I've got server members, and they store the data. And there's an application that it comes with, Geode, and it's called Pulse, and it gives you a visual representation. So you can see here we've got 5 members, we have 14.1 gigabytes of memory, 3 of them are servers, 2 of them are locators, and we have 1 client connected with a subscription that's getting published CQs. And obviously that is that client that's running on PWS. So it's already connected to this, listening for messages. So, and you can see the data. So right now there isn't any entry counts, but the data will be spread across 3 physical servers. So that gives us a lot of scale, right? And setting this up wasn't difficult. Apache Geode is just a jar file. So you basically just put the jar file and the dependencies on each server, and then there is a process within the jar file you can call, and you basically pass it some information about where the other members are. And as those Java processes start up, they just talk to each other and form this consistent cluster that you're seeing here. So setting this up took maybe 10 or 15 minutes, but mostly it was because the upload speed was so slow on this Wi-Fi. I could have had this cluster up and running in 5 minutes. And it could be on GCP, it could be on Azure. It just needs to be on VMs with a network where they can talk to each other. OK, so let's run this, and let's see how this scales. So we'll come into the chat application. Luke. Hi there. Of course. I restarted this right before this talk started. All right. Let's see here. All right. Well, we know it's live. We know it's real. Not a canned demo. So let's go in here and just quickly look at the logs and see if there's something obvious. No errors. That's fun. And the messages are being written. Interesting. So we can actually, if we want to see if the data is getting into Geode, we can do a select star from messages. Let's do a select count star. My objects are serialized, and I don't have. So there's 5 messages there. And if we do a hi, come back here. OK, so now we have 6. So the messages are making it to the backend cluster. I'm not sure why the UI is not behaving. But that's good enough. We know the messages are passing through the cluster. So here's what we'll do. We'll turn on the same load that I put on that crashed the other one and see how this scales. So what I'm going to do is come in here and go into this chat load tester. And luckily, the application name is Geode instead of database. So what we can do now is just run this. And now it's going to hammer on that endpoint of that same application. So autoscale is enabled. We should see that kick in shortly. It should be. It showed a client registered. And it's getting a ton of traffic here. I actually don't trust this interface. Let's see here. OK, CPU is coming up. And if we come here to Pulse, and we do a count of messages now, we can see we're at 1,400 messages now. So the cluster is starting to get some data. And it's not struggling as much on the CPU, so the scale isn't happening because we're not doing that heavy pull to the database all the time. We're listening. So because the app is more effective, it's actually harder to put load to get it to scale. That's a nice problem, but it's destroying my demo. OK, here we go, 14%. So we should see the autoscaler finally kick in here any second. Thank you. OK. So Geode actually helped performance so much, it was hard to break it. Now, what you're going to see is this thing is just going to start up, because Geode could actually take thousands of concurrent clients and not even break a sweat. So I could actually scale this to 50 instances if I want, and there won't be any issues. So why it's not posting to the UI, that's another thing. All right. So we now actually have 3 instances starting. So PCF's a little slow to get going here. So while those are starting up, we'll actually demo an aspect of Geode that is even more powerful. So if we come to Pulse here and we go into the current view, and we go to data, you'll see right now we have about 4,000. Oh no, my Wi-Fi just went down. Come on. Okay, it's back. All right. Okay. So we have about 4,400 connections or entries, and you can see the entry count is going up because that load tester is kind of hammering on it. Now, here's something interesting that we can do with Geode. So to really scale this, I've got a script that basically remotely calls the cluster. Well, first let's go into gfish. So I'm going to connect to my remote cluster. So I'm connected right now remotely to that cluster on AWS. And what I'm going to do is I'm going to stop one of the data servers. So there's a particular server there on one of the machines. I'm going to stop that process. So let's go back. So what we see is the count goes down, and I forgot to put redundant copies, so I lost data. So when you have a partition region, you should always put redundant copies, so there's extra copies across the cluster. Should have tested that before. I didn't just finish this 5 minutes ago, right?
That's right.
Yeah. So there's a setting when I create my regions where I can say redundant copies. So if there's 8 members, I'll have the primary member on one region and then other members as backup copies. So if what just happens, the backup copies, one of them will become the primary, and you don't lose any data. But our service in terms of the application is fine. The application's just kind of chugging along. We now have 3 running instances, so it's scaled a lot better than the last one. Now let's say we want to add this guy back in. Well, I had it as only a single copy in a partitioned region. That means when you do a write, there's only one copy of the object and one of the distributed members. So every member has a bunch of unique records. So if you kill a member and you haven't told Geode to make backups, then you lose.
Like how often are you batching and writing?
Oh, continually.
So it's really the transient.
It's just the caching layer, yeah. So what I'm going to say is start one server. So what I'm going to do is now call AWS again and start that server back up. And what you'll see so you see we have 3 members now. And you'll see the cluster kind of do a rebalance. So what it does now is redistribute that data evenly across the cluster. And that was no disruption to our continual barrage of messages. And if we come in here to our application, we'll see that the log file is just chugging away, just getting those messages. So I hope that shows that using CQs, we can actually make a very performant continuous query. We can make a very performant thing for a use case like this. And also, it's a very easy to set up and easy to scale backing data store. That's it.
All right. I really have to give Luke credit because that's a really complex thing to try to set up for a talk, actually messing with the AWS and getting all those moving parts working correctly. Still got some ironing out, but I definitely want to applaud him for his efforts there. Okay, cloud native data patterns. Let's wrap this up by just kind of recapping kind of what we covered today. The question came about, this is an in-memory data grid, or it's a caching solution, It's much more sophisticated than just caching. Obviously, there's some things you have to be concerned with. Memory, right? I talked about it earlier with expiration, eviction. You have options there to configure those things. We didn't really show those much in detail. There's actually good annotation support for that, and possibly some Spring Boot stuff coming to also help out with that. But certainly makes it easy with the annotation configuration model that Spring Data for Apache Geode or Pivotal GemFire provides. Compression. Like I said, you can compress what's in memory as well, which actually helps reduce the load on the JVM heap. Alternatively, you can actually overflow to main memory, or you can have an off heap equivalent for your region storage. And then serialization, something that we didn't really talk about, but data serialization is actually very important. If you're using Java serialization, it's a very heavy, bloated format, right? Keeps a lot of metadata about your object. GemFire and Geode provides several different serialization mechanisms. One is PDX, and that's enabled by default with Spring Boot for Apache Geode or Pivotal GemFire. And what does that give you? Well, let's say you have a bunch of different types. You literally have hundreds of different types. Maybe you have some types you don't even control, like you're using a geocoding API and you're maybe serializing those types to the server, right? They have to be serializable. Are you going to go and actually implement Java serializable for all of those, even if you own those types? Probably not, right? Like that's a very tedious thing to do. You'll probably make mistakes. Some of the APIs you don't even control, so you don't even have that option. With Spring Boot for Apache Geode Pivotal GemFire, it'll enable PDX serialization by default, which means that it'll just see those types using Spring Data's mapping infrastructure and serialize them for you. Just add a single annotation, at enable PDX, you're done. It's that easy. PDX gives you the ability to query data in a serialized form. So like when Luke was doing that query in Pulse, I could do the similar thing in gfish. You can actually query that data in serialized form without causing a deserialization. The serialization format also enables other clients to connect, like native language clients, like C#, C++. So if you have a mixture of Java applications with other types of clients, you can connect to the same data set in that cluster. So it's a very powerful feature. Just the querying alone is pretty powerful in itself. We talked about this being a grid, where it distributes data across the cluster, but not just distributed in any old fashion. It distributes it uniformly, right? I can replicate that data. I can have redundancy turned on, so I can promote high availability. I can scale that cluster up. I can add a node. The cluster automatically rebalances itself. If something fails, no problem. It'll, again, redistribute the data, rebalance itself, and then the cluster will heal. We kind of ventured into some of the system of record use cases. So the idea really is to start introducing this technology into your application architecture slowly with caching, maybe have some distributed compute. You can start converting maybe some polling mechanisms, expensive operations, and polling back to a more push mechanism with event streaming, with CQs. And we start venturing towards system of record use cases so you can actually add persistence to this guy. You can overflow to disk. So if you're running out of memory, you can overflow, like through eviction, you can overflow that to disk. You can also persist data to disk. So when nodes come back up online, they can actually pull from their local store. And the system will take care of ensuring that the data is in a consistent state, because all these have their own disk stores, right? So it's gonna go through some consensus to figure out who's got the most recent copy of your data and so on. I talked a little bit about multi-site. There's two types of patterns there that are quite common. There's active-active, where maybe you've got geographically distributed user base, West Coast, East Coast kind of thing, right? And you can have two active clusters, and these clusters can be communicating across to each other, sending data back and forth so that you can service two different clusters. Or you can do an active-passive, right? Where you have one in kind of standby mode in case your primary cluster goes down, and you can bring the other one online. And it's just quietly in the background there, staying in sync. And the last aspect is, well, what happens if a member gets severed from the network, right? So this has got very strong consistency guarantees. And when a member actually gets removed from the cluster, it gets fenced off. So no clients can actually connect to that guy and talk. Because his data won't be consistent, right? Like he's missing events, he's missing updates from the rest of the cluster. So he literally gets fenced off. And if the network later heals, or if he crashed for some other reason, you get him back online, he'll go through this fence and merge process where he'll reconcile the differences and before he is allowed to allow client connections. So I'd like to put this slide together. It's just a few things that kind of recap all the different intrinsic characteristics of a technology like Geode. But I really haven't talked much about what is the relationship of all these technologies. So let's give you the what now. So back here in our application architecture, if you put this in a managed environment, scaling this stuff up is quite complex, as you've seen with Luke. Like he's sitting there adding new nodes, bringing nodes down, that sort of thing. That can be very costly to do that. So with Pivotal Cloud Foundry, it's really easy to scale up your applications through auto-scaling. And Pivotal Cloud Cache is, by extension, based on Pivotal GemFire, which is based on Apache Geode. So with these two technologies, it gives you extreme scalability, quickly and reliably, so it's stable, right? That's the most important part, having observability and stability and reliability in all this in your whole application architecture. And not only that, security. One of the things we didn't really talk about today was security, but we've got that covered too. So if you go in through the documentation, you look at how to handle authentication or SSL over TLS over SSL, all simple to do, especially inside of Cloud Foundry, especially. Okay. And when you actually put this in an automated environment, obviously that's going to cut down on your operational cost. It's kind of a no-brainer. So I kind of fast-forwarded, but again, Pivotal Cloud Cache inside of Cloud Foundry is Pivotal GemFire. It's based on Pivotal GemFire. And by extension, Pivotal GemFire is based on Apache Geode. So we just used the open source solution here today, but there's extensions of that with additional bells and whistles. Inside of the application tier, we have Spring Framework itself. We introduced the Spring Cache abstraction today. We talked about Spring Data with the repositories. We use Spring Boot to really simplify all this stuff and get it easily set up. The one thing we didn't talk about was we didn't talk about session state caching, like HTTP session state. So there's also a Spring session for Apache Geode and Pivotal GemFire. And when you actually include that dependency in your application, you can manage your HTTP session state and distribute that as well. These are our references, and I think Luke said he had one thing he wanted to say.
I figured out why that Geo chat wasn't working. Let me just show you. I don't want you guys thinking it doesn't work. So,
it's going to bother him all day.
in my UI layer, I was making sure the same message wasn't written more than once, and instead of comparing with the IP, I was comparing with the username. So that was dumb. So here I have a chat session on PDubs with a username Thor saying, I like hammers. So I can come in here, and I'm on that Geode application inside of PCF. So this is the version backed by Geode. So I'll come in as the Hulk, which is a username I have not yet used. I think my Wi-Fi just went down. Okay, there we go. All right, so I'm in, and I'll say Hulk smash. Come on, man. I just tested it when I was on that chair.
Maybe sit back down again. Only works when you're sitting there.
Yeah, I think my the Wi-Fi keeps going up and down. Like I was just sitting on that chair. I did it with Hawkeye and Wonder Woman, and it can't be, anyway, trust me.
You should have started with Wonder Woman.
I always go to Wonder Woman. I mean, that's the answer here. But anyway, at least Thor worked. So
hey.
It does work when you have a proper Wi-Fi. So yeah.
I like hammers. Did it show up?
Show the what?
Oh, never mind. Okay.
Yeah, this message is not posting.
Actually, can I borrow the tongue real quick?
Yeah, I think my Wi-Fi's.
Yeah.
Oh, there. Hulk smash arrived on Thor. So. Yeah.
Good work, man.
Let's see here. I don't know.
I just want to send a shout out.
Yeah, okay, cool.
The rest of the,
Thanks.
So real quick, we'll be available after this session, of course, for some additional questions. I just wanted to give a shout out to some additional talks. Oh, yeah, sorry. So these are the references to everything. This is all going to be posted after the conference too, so you'll see the actual replay of the session and as well as the slides and stuff like that, but feel free to take a picture. But some additional sessions that you might be interested in, wait till a few more pictures happen here. Okay. You can all take pictures of us too, we're pretty cool guys. So, event-driven architectures with Apache Geode and Spring integration. I think that's going to be a really exciting talk with Charlie Black. Yeah, so definitely check that one out because that's actually going to show kind of more of this eventing mechanism, but with Spring integration. And then metrics for the masses. Udo Kohlmeyer here, who's in the audience today, who's going to be talking about how to get more around the observability of a technology like this. So, anyway. Feel free to come up afterwards and ask us more questions, but thank you again.